So we're going to have a look at scale drawings and scale factors. Maps, all those sorts of things, all have scale factors on them because we can't have the map the same size as what we're actually doing. For example, you might have a box of Nutrigrains, and if you look at the front of the packet, the size of the Nutrigrain is much bigger than the actual Nutrigrain. So we can scale things down and we can scale things up, or make them smaller, make them bigger. Here are some notes that I'd like you to put in your book. So put a heading scale factor. So a scale drawing is the same shape as the original drawing but a different size. So that's the definition of a scale drawing. So it has to have the same shape as the original, but they're just different sizes. And we write that as a ratio. And we always do the drawing length to the actual length. So you might have a diagram, a map, or a model. That's the drawing. The actual is what happens in real life. So a scale ratio of 1 to 100 means that the real or actual lengths are 100 times greater than the drawing. So 1 unit on the drawing is 100 units in real life. It doesn't matter whether it's 1 centimetre equals 100 centimetres, 1 millimetre equals 100 millimetres, 1 kilometre equals 100 kilometres. It's all in proportion. And as long as the units are the same, that's okay. So a scale ratio of 20 to 1 means the drawing is 20 times bigger than the actual one. So in this case, I've got 1 to 100. So the drawing is much smaller than the original. Here, the drawing is much bigger than the original. Okay? So if the ratio is 1 to something, then the something is called the scale factor. So if I've got 1 to 5, then the scale factor is 5. So it's just 5 times bigger than the original. The only other thing you need to remember, and you might need to write these at the top of each of your pages if you can't remember them, 1 kilometre is 1,000 metres, 1 metre is 100 centimetres, and 1 centimetre is 10 millimetres. Let's have a look at some examples. So here's the first couple of examples. A map has a scale of 1 to 20,000. So 1 centimetre on the diagram has a real life size of 20,000 times bigger. Find the actual distance for a scale distance of 2 centimetres, 5 millimetres and 14.3 centimetres. Now you have to remember how to go from kilometres to metres to centimetres to millimetres. So even if you want to draw that little diagram in your books at the top of your page, because 1 kilometre is 1,000 metres, so that's the top arrow, 1,000 metres is a kilometre, so 1 kilometre, 1,000 metres, so I've times by 1,000. 1 metre is 100 centimetres, so I've times by 100. 1 centimetre is 10 millimetres, so I've times by 10. And so divide by 10, divide by 100, and divide by 1,000. Let's have a look. If I've got 1 to 20,000, so on the drawing 1, actual 20,000, and if I want to know what 2 is, what did I do to go from 1 to 2? I've times by 2, and if I times by 2 here, I will get 40,000. But 40,000 centimetres is not really a practical unit, is it? So I could do centimetres to metres and divide by 100. So that is, if I did that, I would get 400 metres. And if I divide that by 1,000, I'd get 0.4 kilometres. 1, 2, 3 spots. Let's have a look at 5 millimetres. So here I'm timesing by 5. So here I'm timesing by 5. So I would get 100,000. But this time, because this is millimetres, this is also millimetres. So now I've got 100,000, let me write it down here actually, it'll be easier. 100,000 millimetres is not your best practical unit, is it? So let's have a think. Okay, if I'm going from millimetres to centimetres, millimetres to centimetres is divide by 10. So I could divide by 10, and then if I divide by 100 again, so if I divided by a total of 1,000, I'd get to meters. So I'm going to divide by 1,000. First 10 to get to centimeters, and then another 100 to get to meters. So that is actually 100 meters. All I've done is just divide by 1,000 to go from millimeters to meters. Okay. The last one was 14.3 centimeters. So let's have a look at that. So all I'm doing is multiplying by 14.3. So here times by 14.3, and I would get 286,000. If I doubled 14.3, I'd get 28.6. And now let's have a look at that. So if this is in centimeters, this is in centimeters. So 286,000 centimeters. Let's have a look. What am I going to end up with? I've got to get rid of at least 3 zeros, don't I, to make it a reasonable number. So let's have a look. Centimeters to meters is only 2 decimal places. So if I divide by 1, 2, 3, 4, 5, if I divide by that, so let me divide by 100 first. So 2860 meters. So 286,000 centimeters is 2,860 meters, because I've divided by 100. That was the first step. And then I'm going to divide by 1,000 to get it into kilometers. So 2,860 meters is 2.86 kilometers. So that's how you do from a drawing to an actual. So here we have another example where a model has a scale of 1 to 500. It's a boat, so a model boat has a scale of 1 to 500. Find the scaled length for an actual length of 50 meters, that's number 1, and 4,550 millimeters. So let's have a look at the first one. So I've got a scale factor of 1 to 500. So here's my 1 to 500. And I want to know what 50 meters is going to be. So I actually want to know if 50 is on this side, what's the drawing, how big is the drawing going to be? Can you see that to go from 500 to 50, I've just divided by 10? This is obviously a very nice one, and they're not all going to be like that, but if you can see that, that's great. The next one I'll show you what happens is when it's not such a nice one. So here, all I need to do is divide by 10. So the D is 1/10. Now, what was the original value in? Meters. So this is 1/10 of a meter. Well, 1/10 of a meter, 100 centimeters is 1 meter. So 1/10 of that is 10 centimeters. 0.1 of a meter. 0.1 of a meter is 10 centimeters because there are 10 tens in 100. Alrighty. The next one, 4,550 millimeters. So I've got here, I know my scale factor is 1 to 500. I want to know how big the drawing is, given that the actual distance is 4,550 millimeters. I don't know easily what the number is that I'd have to multiply to get to that. So I'm going to use my double number line to work it out. So this is the unknown, the drawing size. So I have to start on this side. I have to start here because this is where I know the two values. So the 1 is going to be there. How did I go from 500 to 1? Well, I divided by 500. How did I go from 1 to 4,550? I've multiplied by 4,550. I'm going to do exactly the same over here. Divide by 500 and then multiply by 4,550. So what that looks like, let's follow the arrows back, is 1 divided by 500 and then multiplied by 4,550. That's how I'm going to work out what that the scale drawing is going to be. So when you do that, you use a calculator and you can work that out and you'll get 9.1. So that means when the original question was in millimetres, that means that the drawing is going to be 9.1 millimetres. Okay, so the last example is to actually work out the scale factors. So we've gone from having an unknown actual distance, an unknown scale distance, and now we're actually going to work out the scale factor. So if I said to you 4 millimetres on a drawing equals 50 centimetres in actual distance, note that 50 centimetres is 500 millimetres. Remember, the units must be the same. So when I set up my double number line, I know that 4 millimetres equals 500 millimetres. So 4 millimetres on the drawing is 500 on the actual side. And what I want is a scale factor, so I need a 1 on the left. So how do I get a 1 on the left? I have to divide by 4. So on this side I'm going to do exactly the same, and I'm going to divide by 4. So that would give me 125. So the scale factor is 125.